So today in college algebra, we're going to be looking at verifying trig identities. Now the difference between simplifying trig identities and verifying is, in simplifying, you're just simplifying the trig identities until you think you're done. Just get it as simple as you think you can get it. All right. But in verifying, you're actually told where the end piece is. Okay. That's why they look like equations. So what we're going to do is you're going to make the left-hand side of the equation equal the right-hand side. So you know you're done when you get the left-hand side to look like the right. Okay, so let's look at these. First one, we have sine times cosecant. Again, one of the strategies for doing these problems is to turn everything into sine and cosine. So we have sine of theta. Cosecant of theta is equal to 1 over sine. And then these two cancel, which gives you 1. And 1 equals 1. There you go. It's that easy. Now, they're not always going to be that easy. Verifying gets a little bit more tricky because you know where the stopping point is. Sometimes the problem itself is a little more tricky, can be tougher. Okay, let's look at number 2. We have 1 plus sine and 1 minus sine. Now, neither of these is being squared, which means that you can't use a trig identity, or sorry, a Pythagorean identity on it right now. What we can do is multiply these two parentheses and expressions in these parentheses together. So 1 times 1 is 1. 1 times negative sine is negative sine theta. Sine times 1 is positive sine theta. And sine times negative sine is negative sine squared theta. Okay, the two terms in the middle, because they're opposites, cancel each other out. We're left with 1 minus sine squared. And 1 minus sine squared theta is a Pythagorean identity. 1 minus sine squared is equal to cosine squared, which equals cosine squared. So now we know we're done. All right, let's look at number 3. So we have cotangent squared and secant squared minus 1. So I'm going to look at the secant squared minus 1 and look at the Pythagorean identities. And secant squared minus 1 is going to be tangent squared. Okay, I still have the cotangent squared, and the reason I didn't change it yet is because I wanted to see what it was going to be inside the parentheses. Okay. Now, normally we said you don't use the reciprocal identities where tangent is equal to 1 over cotangent and cotangent equal to 1 over tangent. You'd usually put them in terms of sine and cosine. But this is an exception to this because they're already in terms of tangent and cotangent for both of them. So it only makes sense to change one of them into the other. So we're going to change one cotangent squared into 1 over tangent squared times tangent squared, which happens, they both cancel out, which gives you 1, which equals 1. And you're done. Okay, again, you're iterating that the work that you do to get to that point is the important piece, not the answer itself. Number 4. We have cosine squared and minus sine squared, and that's got to equal 1 minus 2 sine squared. Okay, well, this is a little confusing. But sometimes the answer helps you figure out what to do. Okay, our answer is in terms of sine squared. We have sine squared and cosine squared. So which one of these does not look like the other? The cosine. So I'm going to turn cosine squared into something else. Okay, what I'm going to do is I'm going to use my Pythagorean identity, and I know that cosine squared is also equal to 1 minus sine squared. So I'm going to turn cosine squared to 1 minus sine squared, minus sine squared. Oops. All right, I know now I have 2 sine squareds that are the same thing that are minus. So I have 1 minus 2 sine squared, which is what I wanted to get to begin with. Okay, so sometimes that answer will help you pick a direction that you should go. Okay. All right, number 5. Same idea as the last one. Now I have cosine squared, sine squared, and cosine squared. Which one of these does not look the same? That would be the sine squared. So we're going to put cosine squared back down, minus. So for sine, I'm going to have 1 minus cosine squared. Okay, notice I put it in parentheses because that negative sign is going to cause some things to happen. Okay, if I distribute that negative sign to both terms, I get cosine squared minus 1 plus cosine squared. The two cosines get added together to give you 2 cosine squared minus 1, which equals 2 cosine squared minus 1. All right, number 6. So I have tangent squared plus 4, and then I have secant squared plus 3. So because I have these things that are squared, I'm going to look at my Pythagorean identities. I can tell that tangent squared and secant squared are in the same Pythagorean identity. So I'm going to turn the tangent into the secant. So I have tangent squared. It is going to be secant squared minus 1 plus 4. If I combine the negative 1 and the 4, I get secant squared plus 3, which is what I was looking to get. Okay. All right, so that is verifying trig identities. You have the left side, you want to turn it into the right side. The right side is the answer, the stopping point of your simplification process. Sometimes it's simplifying, sometimes it's just rearranging information to get what you want. Okay. And that is it. So please continue to work on these. The only way you can get better at them is practicing. So please practice these. If you have questions, please ask. All right, good luck.